I'm going to talk about the 127 word later. The question is transformation sequence from word, begin word to word, end word using a dictionary word list. It's a sequence of word begin word S1 to the S2 and SK such that. And every adjacent pair, is it pronounced right? Adjacent pair of the words differs by a single letter. FS1 for one smaller equal than I equal than AK in the word list. Note that the begin word does not need to be in the word list. Okay, so this is a special case. So SK equal to end word. So given the two words, begin word and end word, and the dictionary word list, return the numbers of words in the shortest. Okay, this is shortest transformation sequence from the begin word to end word or 0 if no such sequence exists. So example 1 is we have the here, right? We have begin word is hit and end word is this one. So how it works is translate to the heart, hit to the heart, and to the dot, and to the dog, to the cock. Okay, so this one. Okay, so for this is kind of the right way, right? But if we think about at the beginning, so it starts from the hit. How can we change, right? We can start from the first word to replace, to check. This problem is kind of like find the shortest, use the BFS to solve these problems. So hit words to change, like they have hit current can change. It can change how many words it can for the first level. Hit, right? So hit, this one is also can change, like hit just change only one. Can we change? This is only one option, right? Log con. So we cannot do anything here. But for this one, we can change. Have multiple hot, we can change like lot. Right, hot we can change the dot, no dot, dog. Yeah, we can change this one. And for this one, we also can change something. So it's kind of like when we have the hit, we have to start from the first character. Start from the first character start from the A to the Z to replace it and check the word whether in the word list. If not, so we don't do anything actually, we just move to the next. If is, so we kind of like, which means we create new branch to check, go for the first level, go for the next level. So it's kind of like idea like this one. Okay, so like because we use the BFS, so it's kind of breadth first, right? So it's kind of like it will check all the branch, whether we find the right one. And then if current level has one of the it's okay one, we will not keep checking for the next level. So it's kind of like quite different from the DFS. So we use this one. So implements is by the queue. Implement by the queue. First in, first out. First in, yeah, just the queue. Let's see. Okay, so for the beginning, let's write the code now. Lister string word list. So we can write the readout first. Start from 0. And we need to put the word list in the set. Note that not need to list of size, it's a list. Word. Get I here. Okay, so we go for the next one. Next one is we need to create a queue. Queue. DQ. So how could we do this is the queue over the last one is the queue is I treated this one. This means out, and this is a queue, right? And the last one, this is the last one in. This is a queue. So for the last, we can begin from the begin word. Now also, if the word list has the begin word, we should remove it. So remove word and the result plus 1. Okay, I think everything is good now. So while the queue is not empty, we can keep doing. So we can pull out, like current now we have the begin word, right? Begin word is what? It's the hit. So we want to pull out. And also I want to gather the size first, which means current level is how much? Queue size. Yeah, size is equal to this one, yeah. Which means level, cur level just 1. And then we can pick up 1. So word is equal to per first. Okay, so we need to check for the current word. If current word contains the word, no, if the current word equals and word, which means we find it, right? So we should return the result. Okay, when this level finished, like this while loop, every time you go to this queue, right? So it's kind of like to check the level. So result should be added here. One while loop means going check for the level. So that's why we need cite here. And this is kind of like checking for the branch. Okay, so return the result. Okay, if current noun is not equal to end word, so what we do is to replace it. So we need to replace it. For j equals smaller than the curved word length, j plus plus. Okay. So currently now we want to, for example, we want to replace the first one to check whether in the word. So we need to replace it. So word 2 array. And also we need to replace it for stuff from the and they. This is j equal to ch, and the string is new word. Would char to string. A new word char. A new string. Okay, this one is doing, so we can check if the word contains the new word, right? So we can go into it to go to the next level. Offer new word. And if this one was not contains, we should continue, right? 2 of the last and remove. Should we remove this one? Let me think about it. It's already happened. Yes, we should remove. Yep. Let's see what's gonna happen here. New string, keyword char. Okay, keyword char to string. Oh. Oops. It's up to 5. So what's gonna run? Okay, so char. It's always 2. Why? For the first, yeah, it's for the first. J++. Why? Let's just see. Okay, so let's take an example to check what's gonna happen. For the first begin words, end words, right? Result and is 6. So word has lots. This one, yeah. Remove the begin word. That should be 1, and Q not empty, just 1, right? And the current word is no current word. Current word is hit. J equal to 0, so it should be the A hit, yeah. For the, you know what's going on? A new word is changed. Why this cannot new strange? This one works fine now. Except the 0. Okay, wait a second. So we need to check the last one, right? I'm sorry, I mean not here. This should be return false. Return 0. It should be great now. Yes. And for the time complexity is we have this is TCS01. Suppose we have n words, right? N words. So this TCS01 Q. And for here we check for we have n words. O1. And for here we have size like it's also O1. You check every node, I would say every node, every branch. The curl length means L, right? So it's a kind of like a so TC actually is OL times 24, and the space is the O n times L. You can check. Yep, like this n means words, right? This is O1. O1 words. It is just the idea about this problem. So the main is like this: use the BFS to solve these problems. I think when I interviewed by the Golden Man, I think before. There's a question is about it's also use the BFS to find the shortest path to get the station. So they use the same, almost the same problems about this one. So that is they use the same idea, use the BFS. So every time see the shortest, like this one, shortest path something, there has intuitive, just BFS. Yeah, this is kind of like there's a lot of problems based on this problem. So yeah, thank you.